This light plane, flying aerial reconnaissance over trackless China, is making the first step in airfield construction in the CBI. By flying low over the terrain, which has been previously studied on maps and photos and considered suitable, the experienced engineer can quickly gather the information necessary in selecting a location for a new airfield. Once a likely site has been spotted, the pilot brings his plane down. These light planes can land almost anywhere. The engineer can now make a ground reconnaissance of the area and determine if the location fulfills the necessary requirements: approaches, drainage, good soil, and plenty of room for the dispersal of campsites, dumps, and aircraft. If the area is found to be suitable, the engineer will probably start natives to work leveling and clearing the field so transports can bring in supplies and equipment. Coolies for this work are hired by the Chinese government by the thousands. Their methods are primitive, and they still use tools like these crude hoes to grub out the vegetation, and small hand sickles to cut the grass. All mounds and high spots on the field are removed. When there is a hole or depression, material is borrowed from nearby areas and hauled to the field in small baskets slung on a pole. The low spots are then filled, and the material is tamped in place by the coolies stamping it with their feet. It takes a lot of coolie man-hours, but when there are thousands of them, the landing strip is soon leveled and ready for the first transport. This field, captured from the Japs, was to be used for light traffic as a temporary field for landing supplies, and only light construction work was contemplated. Aviation engineers did the job with airborne equipment brought in by transport. Here, the specially designed airborne equipment is all ready to roll off the planes to be put to work. Jeeps and trailers take the place of trucks. Dozers, carryalls, graders, and other airborne engineer equipment are miniatures of the regular equipment. This baby dozer can't handle anywhere near the work done by a D8 or even a D4, but it still beats the pick and shovel. Plans are carefully made and studied, so there'll be a minimum of heavy construction work. The job is arranged to fit the equipment, and the equipment was designed for this kind of job. To speed the clearing of the field, explosives are used. In this way, a little package does a big job. And all large trees, stumps, and rocks which might interfere with the construction work are blown out. This kind of job is a natural for the airborne equipment. To get the field ready for light traffic, about all that is necessary is to level the dikes around the rice paddies, and the dozers knock them off without much difficulty. The carryall scrapers can then come along and pick up the excess material, using it to fill low places or wasting it. Graders also help on the job, for one piece of equipment can't possibly do all the work. It's a combination of equipment and careful planning that gets results. The final big job is to bring the strip to finished grade. When that has been done, the strip is safe for light traffic. Now let's go to another field, another situation. This particular field was captured from the Japs too. A few men then went to work with hand tools and were able to put it into shape so that transport planes could bring in aviation engineer equipment and supplies. At this field, heavy construction work was required, but natives weren't available in sufficient numbers and the miniature airborne equipment couldn't do the job. So a new technique was employed. The necessary heavy equipment was cut up into small pieces, loaded into transports and flown in. In this way, heavy equipment, such as this sheep's foot roller, could be carried in an ordinary transport plane. After they'd been flown in and unloaded, the dismantled pieces were spread out for reassembly. Each different type of equipment had a crew which used almost production line methods in doing this job. If you look around, you'll recognize parts of equipment you're all familiar with. There's a motorized road grader, partially assembled. And this is one of our very versatile power shovels. The rear wheels have already been attached to the frame of this smooth wheel roller. And here, part of a carryall is being welded together. That's how the heavy equipment was brought in, piece by piece, until all the equipment necessary to do a good, fast job on the airstrip was on hand. These methods are typical of those used in the air movement of equipment assigned to aviation engineer units throughout the world. In the meantime, plans for the construction of the field had been carefully made and the work laid out. The job of clearing and grubbing was begun, with explosives again being used to knock down the large trees in the area. The dozers went to work pushing the trees off the field and out of the way. But it isn't enough just to clear the area of trees and brush. Surplus vegetation and unstable, mucky soil must be stripped in order to start building on a stable base. In areas covered by tall, dense jungle grass, the fastest method of clearing was to cut it down with a mower. There usually were logs and brush hidden in the grass, so a couple of men had to go ahead of the mower and remove them. Then, after the grass had dried out, it was burned. Once the vegetation had been removed, the dozers continued to work. These powerful, efficient machines did most of the rough grading. Working together in tandem, these dozers were used to move earth short distances. Also very helpful with the grading were the carryall scrapers, which brought in sound fill material which had to be moved a longer distance. Then the graders went to work to complete the spreading of the fill and finish the rough grading. Sheep's foot rollers were used to obtain the necessary compaction for the fill. And the strip was gradually worked into shape. Graders were again used to bring the field to final grade and to prepare it for surfacing. Gravel obtained from a nearby gravel source was then dumped in piles to better control the thickness of the layers. However, this method usually results in an unevenly compacted surface. Many times it's better to partially spread the gravel by tailgating it from moving trucks. Motorized graders spread the material evenly on the field. After several passes, the layer of gravel was spread to a uniform thickness. The area was then compacted with smooth-wheeled rollers. When this final step of surfacing was completed, another airfield in the CBI was ready for use. Another problem solved by the ingenuity and resourcefulness of the engineers, who in this theater have learned to improvise in the face of conditions best described as not ideal. Not all airfield construction is done with mechanized equipment. Sometimes they must be built by entirely different means. Here, coolies are being used to construct a runway for B-29s and other large bombers. But the first requirement when using coolies is to have thousands of them. Working almost entirely by hand, every operation takes time. The more hands you have, the faster the work is done. Coolie methods are primitive, and they still use their all-purpose hose and baskets as they go about the job of leveling the ground. Some of the coolies may use homemade wheelbarrows to transport stones and dirt. But most of them stick to their traditional baskets to haul material from one place to another. The overall methods of bringing the strip to grade are very similar to those already shown. But of course, with native labor, the time element is always longer. For heavy construction, we use a base course composed of large stones, 6 to 8 inches on a side, which we call a Telford base. These stones are chinked or laid together with stone fragments to hold them firmly in place. Then, since smaller stones are needed to fill the voids near the surface, groups of natives with hammers work their way along the strip, breaking up some of the larger rocks on the surface. Here, coolies are mixing an earth mortar, called slurry, to fill the small remaining voids in the Telford base. Since some of the soil contains gypsum, it has a certain amount of bond when it dries. This slurry, after being mixed to a soupy consistency, is poured into wooden buckets and carried to the runway. There it is poured between the stones and acts as a substitute for bonding materials such as cement mortar or asphalt. When all the voids have been filled and a fine aggregate has been put on top, the surface is rolled until compact. Some of the huge native rollers have been carved out of solid rock, and it probably took several generations of stone chippers to do the job. But that's how they were made. It's hard to realize that runways for the mighty super fortresses, the B-29s, can be made by coolies using some of the most primitive construction methods. But engineers supervise their work and adapt their methods to the job at hand. And that tells the story. A thorough understanding of native methods. Adaptability, resourcefulness, and ingenuity are the trademarks of the engineers in the CBI.